Hello and welcome to Chemistry with Dr. Clark. In this video, I'd like to talk about homogeneous equilibrium expressions. Now, I do have another video that talks about heterogeneous equilibrium expressions. And the difference is, if you're homogeneous, all of your reactants and all of your products have the same state or phase. So if you have reactants that are gases, then you also have products that are gases. If you have reactants that are aqueous, then you have products that are aqueous. Okay, they tend to be the more straightforward of the two. Heterogeneous equilibriums, those are ones where you have a mixture. So you might have a liquid reactant and a solid reactant, and it gives you a gas product and a solid product. Okay, those are a little bit more complex, and so I've covered them in a separate video. Okay, so if we do want to consider an equilibrium, okay, what I've written here is just a general one. It talks about some reactants turning into some products. The capital letters represent the chemicals. So chemical capital A, chemical capital B, chemical capital C, and chemical capital D. The lowercase letters represent how many. So when you balance the equation, how many of chemical A did you have, how many of chemical B, and so forth. So if we want to do a bit of a more concrete example, let's say that we're going to talk about H2 gas reacting with Cl2 gas to form, in equilibrium, two HCl gases. Now it is a homogeneous equilibrium because we started with gases and we end it with gases, right? They're all gases. And this thing is balanced. You have two hydrogens at the beginning. You've got two hydrogens at the end. You've got two chlorines at the beginning. You've got two chlorines at the end, right? 2 times chlorine. So this is an equilibrium. It's generalized by this, right? So chemical A would be the H2. Chemical B would be the Cl2. Chemical C would be the HCl. And in this case, we don't have a second product. Now, we can write what we like to call an equilibrium expression. Okay, it's like an equilibrium equation. So we have a constant here, K, and it's going to be equal to the concentration of each product divided by the concentration of each reactant. Okay, the square brackets just mean concentration. So it's very important that you realize that it's going to be products on the top and it's going to be reactants on the bottom. Okay, you don't want to get them backwards. So the C and the D are products, they're on the top. The A and the B are reactants, they're on the bottom. And this is all about concentrations. That's why we have the square brackets. Now, they are raised to powers, right? So A is raised to the power of A, B is raised to the power of B, and the powers come from the numbers used to balance it. So the number of A's that you have becomes the power of A. So if we do it over here with our more concrete example, I can say that KEQ equals. So the products are going to go on the top, the reactants are going to go on the bottom. The only product I have here is an HCl. So HCl will go on the top. Now, for HCl, I know a number of things about it. I could know its moles, or its mass, or its volume. Like, I have a bunch of things I know about it. In order to put it into this equation here, we are going to be talking only about concentrations. And to show that, I am going to put square brackets around the HCl to indicate that I want to talk about the concentration of HCl. Now, when I balance this equation, I did have two HCl's, and therefore that 2 becomes the power in my equilibrium expression. So it'll be the concentration of HCl squared. In the denominator, that's where I'm going to put my reactants. Now I have 2. I've got H2s and Cl2s. So if we write the first reactant, that's an H2. Again, I'm going to put square brackets around it to show that I'm talking concentration. And in this equation here, even though I didn't write it, there really is one H2, which means the power here would be power of 1. Now, I kind of breezed past it, but if you do have more than one product or you have more than one reactant, there is a multiplication sign in between them, so they are times. So here, because I do have a second reactant, when I write down the Cl2, when I put it in square brackets to indicate that it's a concentration, there is going to be a multiplication sign in between them. Okay? And again, there is no number in front of the Cl2, so it is really just a 1, right? We don't write in our 1s. So that means my power here will be 1. So my equilibrium expression for this equilibrium will be the concentration of HCl squared divided by the product of concentration of H2 to the power of 1 and concentration of Cl2 to the power of 1. Okay, so this whole thing is called an equilibrium expression. I also kind of glanced over or breezed past the equilibrium constant. When you write this kind of expression and you put in the concentrations at equilibrium, you will get a constant value. And this is really, really neat because no matter how you alter these concentrations, right? Let's say you've decided you're going to add a bit more HCl or a bit more H2 or a bit more Cl2, the equilibrium will always readjust itself so that when you put the numbers into this formula, it will always give you the same value, the same constant. Right? So if you have a little bit more or a little bit less of something, it doesn't matter. When it goes into the calculation, it'll always give you the same value of the equilibrium constant. And that's why we call it a constant, because it'll always give you the same value even though the concentrations may differ, right? So I give you 2 or 3 problems with the exact same equilibrium, but with different actual concentrations. They will always mathematically give you the same answer. Okay, so we call this thing the equilibrium constant. K is the equilibrium constant. This equation with the equal sign, that's the expression. So the expression is the equation. The constant is just the K. Now for this one here, I did refer to it as KEQ. This does have a couple of variations. Sometimes instead of being called KEQ, it's just called K for the equilibrium constant. And sometimes it's called K with a C because this whole thing is about concentrations. So KC, the C says, don't forget to use concentrations. Okay? So there are a couple of variations. Depending on which one that you've seen in your worksheets or your class or your problems that you're doing, you just go with the one that matches what you've learned. All right, so let's take a look at a couple of examples. So in this problem, I would like to write the equilibrium expression, so K equals products over reactants, for each of these equilibria. Okay, so if we start with the first one, KEQ equals. You're always going to put products in the numerator and reactants in the denominator. If you're going to make a mistake in here, that's the number one mistake. You're going to put them in the wrong place. Okay, so be really careful that you're going to put products on the top and reactants on the bottom. So kind of like the example I just gave, this has only one product. The only product is HBr. So I'll put my HBr here. You will put square brackets around it to indicate that this is all about concentration. And whatever numbers were used to balance it, those become your powers. So this will be squared. In the denominator, you have your reactants. So my first reactant is H2. Square brackets to indicate concentration. There is only one of them, so it's power of 1. If you have a second reactant or product, it gets multiplied in, right? So I have a second reactant. That's Br2. It is concentration, put in our square brackets, right? And because you have 2 of them, it does get multiplied. And in my equation, when I balanced it, there really is just one of them, but we left out the 1. So this would be power of 1. Okay, this is your equilibrium expression. Okay, the whole thing is my equilibrium expression. Now, we are chemists. We tend to be lazy people. Okay, equilibriums are a big part of chemistry, and we don't want to have to write out the word equilibrium every single time. So it's often reduced to EQ, LBM, equilibrium expression. Okay, so the whole thing is the equilibrium expression. This is your equilibrium constant. Okay, They both have equilibrium in the name. Equilibrium constant, equilibrium expression. Now you do have to be careful. In the chemical reaction, if you have two reactants, they are added. If you were to have two products, they'd be added, right? But in your expression, if you have two reactants, they become multiplied. All right, so let's try another one. KEQ, or just K, or K for concentration, KC, right? Whichever one that you're used to using, keep going with it, equals products over reactants. There is only one product, NH3. Square brackets to show that it's concentration. There's a 2 in front, so it is going to be squared. In the denominator is your reactants. First reactant is an N2. Square brackets to show concentration. You have one of them, so power of 1. Now, we leave out the 1 here because we know if there's no number in front, then it's automatically a 1. You can do the same thing here, right? You don't have to write a power of 1. If the power is 1, you are allowed to leave it out, because if I don't show you a power, then it's assumed that it's a 1. Times, the second reactant is an H2, square bracket it, and this time there's a 3 in front. So this will be power of 3 cubed. Products on the top, reactants on the bottom. Okay, let's take a look at the next one. So we'll say KEQ equals products over reactants. Right? These are very nice, very straightforward. Once you get into the rhythm of them and you've practiced a bunch, it becomes a very easy skill. Okay, so SO3 is my only product. Square bracket it. There's 2 of them, so square it. In the denominator, your first reactant, SO2, square brackets, and a 2 because you've got 2 of them, so it's squared. Your second reactant is an O2. There is one of them, so the power would be 1, but in this case, I'm going to leave out both. That would be my equilibrium expression. And if we do the last one, KEQ is products over reactants. So again, I only have one product, NOCl, square brackets, square it because there was a 2 in front. The reactants go in the bottom, NO, square brackets to show concentration. There were 2 of them, so we'll square it, times the second reactant, which is a Cl2. Square brackets to show concentration. There's one of them, so it should be power of 1, but I'm going to leave them both out. Okay, so in the world of equilibriums, this is pretty much universally the first step. If you're going to do any sort of calculation with an equilibrium, the first thing you need to be able to do is write the equilibrium expression. There are a bunch of problems then you can do past that, right? If I were to give you the concentrations, you could calculate K. If I give you the K, you can calculate the concentrations, right? There are a bunch of other things that you can do with these. So that's why I have another video that's related to this one. In the next video, what I will do is talk about what happens if I do give you some concentrations and I would like you to calculate the K. So the link to that is in the description below. And once again, I thank you for joining me here at Chemistry with Dr. Clark.